Hey Science 10, welcome to the last physics unit or physics video for this little section here. We are going to be talking about forces in motion. The reason why that we put this in this week is that it fits nicely in with acceleration. It has to do with a lot with acceleration. So whenever acceleration happens, a net force has to be occurring. So here's a good picture I like to think about. This right here. So if 300 newtons is being pushed, and the unit for force is 300 newtons, by the way, or is newton, sorry, by the way. We'll talk about that in a minute. So if somebody is pulling 300 newtons this way and 300 newtons this way, there will be no change in position, so no acceleration. There's only acceleration or change in position when one force is applied that's stronger to the other force here. So that's good to remember. Okay, so when we go back here, little introductory. Oh, I see what's happening. Little introductory piece here. So what a force is, it's a push or a pull on an object, quite simply. Force equals mass times acceleration. So force kind of represents what would happen if this car ran into a wall. Okay, so that's one way of looking at it. Okay, so force, the car weighs 1,000 kilograms. The car is going at 50 kilometers an hour, so you times those together. So how you write a force is a Newton. Okay, it's called a Newton because it's based on Newton's second law of motion that states that the higher the net force, the greater acceleration on an object. Written mathematically, his second law is force equals mass times acceleration. You probably have heard that before somewhere in TV. And what Newton is 1 kilogram per meters per second squared. Okay, so that's essentially 1 Newton is equal to this. So when you're writing it, that's what a Newton represents. So rather than writing your answer in kilogram per meter squared, you just write an N. So these two things are the exact same thing. All right, so you have acceleration in there, and you have your weight of the object there, or your mass of the object there. So your mass and your acceleration. Okay? So moving on. So another thing to think about is rearranging this formula so you can actually solve for each part of this as you go. So force equals mass times acceleration. Acceleration rearranged will be force over mass. Okay, and the same thing will be for mass. Okay, so usually you'll always have the mass of the object, but you can always rearrange them to solve. So always remember to rearrange them. Once you've rearranged them once, you can just write them down in your data booklet if you want. I'd have no problem with that at all. Okay, so remember that. We're going to get into weight and force due to gravity now, and the difference between weight and mass. Moving on. Okay, that's what we're going to dive into. So any object. So sorry, just to segue into this next part, we're going to talk about weight and force due to gravity. Any object that's near the Earth's surface will feel the effects of gravity. This means that every mass will feel a gravitational force pulling towards the center of the Earth, no matter where it is on or above the Earth's surface. Gravitational force is just another force, but it acts vertically, so straight in towards the core. It causes any other objects near Earth's surface to accelerate, like we talked about before, at 9.81 meters per second squared. Okay? Hence, gravity is 9.81 meters per second squared. Gravitational acceleration, and that represents gravitational acceleration near the surface. Fg is the force of gravity on an object in newtons. Okay, it equals the mass of the object in kilograms. Okay, so what we are going to be doing, we're going to be doing some practice questions of force of gravity on an object. So what you do is you have the mass of the object and you have the gravity that is there. So you can always rearrange this formula and you can solve for the gravity. Let's say if you were on Mars, you can solve for mass if you have the other two pieces of information, just like you've rearranged all the other problems. Okay, you can do that. So if you have a question here, so basically this is saying this right here, weight is force of gravity. So force of gravity is weight. So a long story short, mass and weight are not the same thing. So a mass will remain constant no matter where you are in the universe. Weight will change based on the gravitational pull pulled on you. Okay, so that's what weight is. Weight. So if you're on the moon, you are going to weigh less than you do on Earth, but you have the same mass. So mass basically represents how much amount of matter you have, and weight is how much pull you have or how much force you have at the surface of the planet. So how much force you're exerting on the planet's surface when you're standing there. Okay, so that's why we use a scale to weigh us. Weight describes the force of gravity on an object measured by the force of the object exerts on Earth's surface. So this is right from your notes. And weight is measured in newtons, okay? So, which is mass of an object in kilograms. Okay, so I will let you do this practice question on your own here. What is the weight of an object? So you just go through this formula. I don't think you need me to show. Well, maybe I'll just show it. Okay, so weight equals Fg equals mass times gravity. Okay, so we're going to do this one. I decided just to show you. So I wrote out this equation for you. I know it's messy. This should be decimal 240 kg. Remember, our answer is going to be in newtons. And newtons is in kg per meter squared, meters per second squared. Okay, so we have to convert our grams into kilograms. Do not forget to do that. Must always be in kilograms. So it'll be 0.24 kilograms times 9.81 meters per second. Okay, you go through that equation, times this by this, and you'll get your answer, okay? I decided to do that when I noticed that this was written in grams there when I was skimming through to make sure that you are converting everything to the proper unit. So it must be in meters per second for your acceleration, and your weight must be, or your mass, sorry, must always be in kilograms in order to solve these problems. Okay. So I think I'm just going to look through my notes, make sure that you are set. Okay, the only thing that I think that you guys might need to know is how to rearrange them and just to write them out. So I'm going to do that for you. So just to conclude this little mini lesson here, I've rearranged the formulas for you, so you might want to copy these down. If you're solving for weight, okay, the formula is mass times gravity. If you need to solve for mass in an equation, the formula is mass equals force of gravity, or weight, sorry, over gravity. And if you're solving for gravity, let's say you're trying to calculate the gravity for the planet Jupiter, you have weight divided by mass. Okay, so these are your three formulas. I would write them somewhere, especially if you don't know how to actually go through and rearrange this formula. Just write them down and you'll get used to them. Okay, that's all for now. Take care, guys.